Hello everyone, myself Kamna Singh, Assistant Professor in Computer Science and Engineering Department in Ajay Kumar Garg Engineering College. Today we are going to discuss the shift micro operations. First we have to know about what are the micro operations. Micro operations are nothing but whatever the operations performed in the registers, that is called as a micro operations. So you can say that whatever the operations, whatever data is stored in the register and you are doing such particular operations on the register, that is called the micro operations. There are different types of micro operations. These are the four micro operations are there. That is, the first one is the register transfer micro operations. In this particular register transfer micro operations, whatever operations are there, suppose that there is a R1 is there and you are performing some particular operations, means you are transferring some data from R2 to R1, then it is called as a register transfer operation. Means you are content of the R2 register will transferring into the R1, that is called as a register transfer micro operations. And the next one is the arithmetic micro operations. Actually, micro operations means whatever content is there and you are applying some micro operations are there, and the arithmetic, whatever the addition, subtraction or transferring the particular register, that is called the arithmetic micro operation. It is just like, for an example, if the R1 equal to R2 plus R3 or R2 minus R3 or increment or decrement micro operations are there, means arithmetic micro operation you are performing, then it is called as a arithmetic micro operations. That is, in this particular example, you can see that there is a R2 and R3. Whatever the content of R2 and the content of R3 will be add, and that particular result will goes into the R1 as a result. Next is the logical micro operation. Logical micro operation is nothing but whatever the particular and or not operations you are performing on the content of the register stored. That is, suppose that for example R1 is having R2 and R3. Whatever the content of the R2 and the R3, these having a AND operations will be performed and the result will be stored in the R1. And the next one is the shift micro operations. Today we are going to discuss actually the shift micro operations. Shift operation means whatever bits are stored in the register, you are shifting that particular bits, or you can say the bit position will be changed during the shift micro operations, and whatever the data stored in the register, that particular operations will be performed as a shift micro operations. So you can say the shift micro operations are what? There is a shift micro operation, there is a serial transfer of the data. Serial transfer means what? Whenever one particular hardware component is transferring the data with another hardware component, these particular bits are transferring. So this is called the serial transfer of data, and so we can shift the contents of the data, whether right or left shifts will be there. So according to this right and left, there are three types of shifts are there. These are the particular simple types of the shift micro operations. These shift micro operations are three types of shift micro operations. The first one is the logical shift micro operations, and next is the circular shift, and the next one is the arithmetic shift micro operations. The logical shift is again having two types, that is a logical shift operations, and this is also called as an SHL. You can write it as logical shift left, and there is a right logical shift micro operation. We can also write it as SHR. Whenever we are going to perform any particular shift micro operation, like if the R1 having some particular data is there and you are transferring some particular information and there is a shift micro operation, so you can write it as SHLR1. Means there is a logical shift left micro operation and the right logical shift micro operations. The next one is the circular shift micro operation. In the circular shift micro operation, again there is a two types, and it can be written as CIL and CIR. That is a left circular shift micro operations and the right circular shift micro operations. And the next one is the arithmetic shift micro operation. Again, there is a two types, ASHL and ASHR. That is a left arithmetic shift micro operations and the right arithmetic shift micro operation. So you can say overall in the shift micro operations there are three types: logical shift, circular and arithmetic, and each having a two types, that is a left shift or a right shift operations. So now we will discuss one by one these particular operations in the logical shift, circular shift and arithmetic shift, and each having the different types, that is a left shift or a right shift. Now, in the logical shift left and in the logical shift right, what will be happen? In the right shift, logical shift left operations, there is a serial input. This serial input is nothing but you are inserting 0 at the MSB side. MSB side means what? Whenever you are writing here, whatever the information is there, like 1100 is there. So this 1100 is nothing but there is a, this point, this first right value is called as a MSB. That is the most significant bit, and the 0 is as an LSB. That is the least significant bit. So 1100 is what? 1100 you can say whenever the serial input is going on, the 0 is inserting at the MSB side, and this particular LSB 0 will be lost. You can say in this particular. So taking the simple example is there is a next is the types of shift micro operation, that is a circular shift and the arithmetic shift. Now, the one by one, the first one is the example of the right logical and the left logical shift operation. In the right logical shift, inserting at the MSB side, 0 is inserting and the last bit will be lost. If there is a 8-bit values, these boxes is represented as the 8-bit values are there. So 8-bit value will be in the MSB side, 0 will be inserting and this last LSB will be lost. And the left logical shift is there. In the left logical shift, the reverse process will be applying. That is the 0 is there. So this particular 0 is inserting at this particular LSB side and this MSB will be lost. Left logical shift, and it is also called as an SHL, or you can say the logical shift left, and it is also called as an logical shift right or SHR. So SHL for the logical shift left and SHR for a logical shift right. And how you can write it down this particular, if the we want the R2 is the content, then the SHR R2 we can write it logical shift right, and if the R3 we want whatever the content of the R3, we want it shifting into the logical shift left, so we can write it here as an SHL R3. Now this is the example for the first one, that is a logical shift left. First one, micro operations having a 4 types. These are the register transfer, arithmetic, logical and shift micro operation. Again the shift micro operation having a 3 types, that is a logical shift, arithmetic shift and circular shift. So first one is the logical shift operations. Logical shift left having again the 2 types, that is the first one is the logical shift left. How it is going to be inserted for an example. These particular questions is not, just like the 2 marks or a 5 marks questions will be there. We can also explain that whatever the questions will be there. So logical shift left micro operation, suppose that this is the example of R1 equal to 1100. In this particular R1 equal to 1100, what will happen? That is 1100 is there. So 1 is the MSB and 0 is the LSB is there. At the logical shift left, LSB side you are inserting 0 and this particular MSB will be lost. Means in the SHL R1, this is the result. Suppose that I am taking the next example. Suppose R2 is 0011. Suppose at that moment, if we are applying logical shift left, In this particular example, 0 will be inserted at the LSB side and this particular value will be lost, that is the MSB. So the result of SHL R2 is what? This particular 0, 1, 1, 0. Because the MSB will be lost and the right side means LSB side, there is a 0 will be inserted. The next example is taken as a particular, this is the 8-bit value. 8-bit value or a 16-bit value or a 4-bit value, nothing but again the same procedure will be following. That is the whatever the R1 register and you have to apply the SHL R1 logical shift left. At that moment, you have to insert 0 from the LSB side and the MSB side will be lost. This MSB side will be lost. So, SHL R1 having a result of this one. Next is the logical shift right micro operations. The reverse process will be applying here as a logical shift right micro operation. In this logical shift right micro operations, suppose that this is the 4-bit number is there, whatever the number is there. In this particular time, there is a inserting 0 at the MSB side. Remember that in the logical shift left, your MSB will be lost and this particular having a LSB side, you are inserting the 0 or a serial input you are inserting. And in this particular logical shift right micro operation, MSB side, you are inserting the 0 and this particular LSB will be lost. LSB will be lost. So, the R1 equal to, suppose that this is the example 1100. In this particular time, 1100 having what? This, in this side, MSB side, you are inserting the 0 and this LSB side will be lost. So, the result of the SHR R1 is written as SHR R1 can be written as 0110. The next example for a 8-bit for logical shift right micro operation, whatever the R1 is there, again the same procedure will be followed, means this side you are inserting 0 and this particular LSB side will be lost. LSB is the least significant bit of that particular binary stream and MSB is the most significant bit. This is the most significant bit. So, the most significant bit side, you are inserting 0. So, inserting the 0 and this particular 0 will be lost. Your result will be SHR R1. This is the logical shift right micro operations. Now, again, the shift micro operation is of 2 types. What are 3 types is there. The first one was the logical shift left and the second one is the circular shift. Now the circular shift having again the 2 types, that is the right and the left. And this right circular shift can be written as CIR and it can be written as CIL. Circular shift left micro operations. So in this particular time, because the logical shift micro operations, the bits was lost. Either it is of the MSB or at the LSB side, because these 2 bits value will be lost. So, this particular bits cannot be lost with the help of the circular shift micro operation. In the circular shift micro operation, you are shifting the position of the bits, but no particular bits will be lost. In the right circular shift, what will happen? Whatever the LSB value is there, this LSB is converted into the MSB. This LSB, whatever the least significant bit is there, the last bit of your binary stream will be converted into the MSB, and the left circular shift micro operation is what? Again, the reverse procedure will be there. Whatever the MSB of your shift operation, this MSB will goes and converted into the LSB. It can be written as R2 is CIR, R2, whatever, you can write it as R1 is there. And so you can write it as a circular shift right R1 or CIR R1, and you can write it here R3 CIL R3. This is the simple notations that how you are going to write that circular shift left and circular shift right. The next one is the circular shift left micro operation. In the circular shift left micro operation, this is nothing but that is the CIL is there. In the CIL, circular shift left micro operations, what is going on? Whatever the MSP value is there, this MSP value is going to the LSP. Means what? Whatever, suppose this is the example, that is R1 equal to, suppose 1100. So first one, this particular bit will goes here. That is. So the resultant will be CIL R1 is 1001. Or we can take a simple example, that is suppose 0101. It means what? Actually what is going on? This 0 MSB will goes here. So suppose this is the R2 value. So CIL R1 will be what? CIL R1 will be what? That is 0 will be going here at the MSB side. So 1010 will be the answer. That is the circular shift left operations. There is a 8-bit value. If the second example we are taking in the circular shift left, that is the 8-bit operations are there. In this particular 8-bit, this MSP side will be going to the this value. Suppose I am taking in the another example. This is what? Suppose you are taking 10101101. Suppose this is the example and the value is R2. And you have to apply the circular shift left. CIL R2. Circular shift left. In this circular shift left operation, this MSP will goes here. This MSP will goes here means what? MSP is here and all these values will be shifted right. Means what? The circular shift left operation will be performed as 0, 1, 0, 1, 1, 0, 1 and this one will be here. So this is the circular shift left micro operations. Next is the circular shift right micro operation. That is the reverse process of the circular shift left. In this circular shift, no particular bits will be lost. In this particular circular shift right, whatever the value of the LSP will be going to the MSP. This value LSP will be going to the MSP. It means what? Whatever the value, suppose R1 is 1100, so this 0 goes here. And the result comes 0110 is there. No value will be lost. We can take the another example. Suppose that R2 equal to, there is a 4-bit register is there. R2 is the 4-bit register. So 0110. Suppose this is the register value. At that time, you have to perform the CIR R2. Circular shift right micro operation. In the circular shift right micro operation, what will going on? This particular 0 will be here. Means LSB will converted into the MSP. So this 0 will be here 0, 0, 1, 1. And all these bits will be shifted right. This is the circular shift right micro operations. Now the next one, the last one is the arithmetic shift. Actually shift micro operation is of 3 types. Circular shift, logical shift and arithmetic shift. And each having a left and a right shift micro operation. So there is a last one is the arithmetic shift. Actually arithmetic shift is used for what? Arithmetic shift is mean for the sign binary number interior, signed values. In this particular circular shift left and circular shift right, we are taking just as a positive values are there, positive content in the registers. But by default we are taking. In the arithmetic shift, we can also take the negative values or also can be considered in the arithmetic shift. Arithmetic shift is again the 2 values, that is of what? Arithmetic shift having a left operation and the right operations are there. So, and the first one is there. In the arithmetic shift, one more thing we are going to consider, that is overflow bit. Overflow bit is nothing but whenever we are going to perform any operations, suppose that the R1 having a 4-bit register and we are going to insert some 5-bit value or shifting the value, and the resultant will be considered as a 5-bit. So there is an overflow. Overflow means whatever the size of the register, the content of the bit you are going to store is having some extra values are there. So there is an overflow. In the arithmetic shift, we are going to consider that there is a overflow bit is here or not. How we are going to consider? The first 2 bits. The first MSB and the second MSB. This is the first MSB and the second most significant bit. You are checking these 2 significant bits are there. These 2 MSB is there and these MSB are there. With these particular, if all operations will be performed, then we are getting the V. It means what? If there is a operations performed and these 2 bits, XOR operations we are going to, so if these 2 bits are differing, means 0, 1 or 1, 0 is there, it means there is an overflow in this particular register after performing the operation. Otherwise, there is no overflow. Means what? What it is saying that if there is a 1, 1, 0, 0, first MSB and the second MSB, both values are same. If the both values are same, then the overflow bit is 0. If the another example we are taking, that is a 0, 1, 0, 1. First 2 values are differing. That is a 0, 1 is there. So the overflow bit is 1. Means if the first 2 bits or you can say the first MSB and the second MSB will be differing, then may be possible there is an overflow. And the overflow bit can be written as OVF, that is the overflow bit is there, that is a 0 or a 1. Notations can be written just same as we can write it CIL R1 and CIR R1 is just like the R2 register is there. So you can write it as ASH R2 and the R3 having a ASH L R3. Now, this is the example we have taken, arithmetic shift left. Arithmetic shift left is actually the same, just like you are studying the logical shift left micro operation. In the logical shift left micro operation, what will going on? In the LSB side, you are inserting 0 and this value will be lost. Only the difference is there in the arithmetic shift micro operation, we are always finding out the overflow bit. Either it is 0 or a 1, but we are always going to find out is there is an overflow or not in the content of the register. So, in this particular example, if R1 value is 0010, so the MSB will be lost and there is a, at the right side, there is a 0 will be inserted, just like you are taking as a logical shift left. So, we can write it here as an ASHL R1, that is 0100 will be there. Means what? 0 will be inserted here, 0, 0, 1, 0 and this particular value will be lost. Here, how we can calculate the OVF bit? Because first 2 bit before the operation, before you are going, whatever performance, whatever operations you are going to perform before the operations, before the execution of the content, we are considering this as a 0, 0. Either you can see that there is after the operations, there is an overflow. You are not going to perform this particular. You have to find out before the operations, there is what? This is the 0 and this is the 0. Means first MSB and the second MSB having a values are same. So, the overflow bit is 0. In the second example, if you are taking this arithmetic shift left operations, here you can see there is a before the operations, the first 2 bits are differing. Either it is a 10 or 01, nothing values are there. That is the first 2 bits should be different. If the first 2 bits are differing, then there is a overflow bit is 1. Now the arithmetic shift left R1 is there. In the arithmetic shift left, what will happen? The 0 will be inserted here and this particular value will be lost. Means actually the resultant will be happen as 0, 0, 0 and 1. This will be the result as ASHL R1. Suppose this is the example we are taking. Suppose the different example we are going to take. 1, 0, 0, 0. Suppose this is the example. In this particular time, the first two bits are differing. It means overflow bits before the operation is 1. Overflow is a true value or a enable value is there. And then ASHL R2 is what? This 1000, here you are inserting 0 and this bit value will be lost. Means there is a 0, 0, 0, 0 will be there. This is the ASHL R1. Next is the arithmetic shift right micro operation. Here we are going to take the first MSB is taking as a sign bit value. This is the sign bit value, so we can consider it. Including this value, we are transferring or we are shifting that particular bit positions to the register. In this particular, whatever values is there, the first MSB, including this, we are transferring or shifting this, and the last bit or a LSB will be lost. If the example is taken R1 equal to this one, that is a 0011. So arithmetic shift right R1 is what? In the arithmetic shift right operation, the first bit including this operation, that is a first is the 0 and this 0 will be there. And next this 0 is there and this 1 is there and the 1 will be lost. If I am taking the another example, that is the R2 equal to 1100. Suppose this is the example. So this particular as considered as a sign bit. So including this one, you are shifting the operations, that is the 1, 1 and 0 and this value will be lost. This is the arithmetic shift right. Now the arithmetic shift left, right, and how the questions will become in the particular your semester and sessional papers. I am taking the simple example. That is, if you are applying that the consider whatever the 8-bit values is there and you have to perform some operations. Fine. If some operations is performed, suppose that you have to perform the R1. This is the SHR1, R1. Shift right R1. Shift right means this side you are inserting 0 and the last bit value will be lost. That is 000 and this. The next operation is the ASHR R1. Here you can write ASHR R1. Arithmetic shift right, and in this particular ASHR R1 means what? Including this value, the first bit, you are writing it here and including this you are shifting this 0, 0, 1, 0, 1, 1 and 0. The last LSB will be lost. The next one is the CIL R1. Circular shift left. In the circular shift left, actually this particular 0 goes here. This 0 will goes here. So means what? The result will be 0, 1, 0, 1, 1, 0, 1 and 0 will be there. The CIL R1. Next is the CIR R1. If the CIR R1 means what? Your resultant will be actually the CIR R1, circular shift right. This particular MSB will come over here as an MSB. So the resultant will be 1, 0, 0, 1, 0, 1, 1, 0 and the 1 will be lost. Next is the SHR R1. In the SHR R1, shift right R1. In the shift right, actually we are going to perform the actual, whatever the register is there, all these operations perform in the R1, whatever is given. So SHR R1 is shift right R1. In the shift right R1 is what? Logical shift right and the logical shift left. SHR R1 is already we are considering it here 000 10 110 is there. And the next one is the ASHL R1. In the ASHL R1, Shift right R1 is what? 0, 0, 0, 1, 0, 1, 1, 0 is there. And the arithmetic shift left R1. In the arithmetic shift left is what? Simply it is just like the shift left operation. Means what? This side you are inserting 0, 1, 0, 1, 1, 0, 1 and 0. And the MSB will be lost. So just revising this particular. First, whatever the R1 is there, you can write SHR R1. When the ASHR R1 means this particular, including this bit, we are shifting this operation and the last bit will be lost. And the CIL R1, in the CIL, this MSB will goes here in the MSB side. This is the CIL R1. And the next one is the CIR R1, circular shift right. In the circular shift right operation, what will happen? This circular shift right is, means this particular value will be here. LSB will be going here as a 100 and SHR R1, which we already consider it here as an SHR R1 and the ASHL R1. These particular type of question can become in this particular questions when the shift micro operations are there. And the next one is the followed by. There is a one particular term that is a followed by. It means what? Whatever operations is going to perform, you are going to the followed by. Means whatever output is coming after the operation, these particular output is the input with the next operations. First, R1 is this value. Now the SHL R1 is there. What is the shift left R1? In the shift left R1, actually what we are doing, this particular shift left R1 is what? You are considering it, this particular shift left, the 0 will be inserted and this value will be lost in the shift left operations. So the first one is what? Sequence of the question is there. The first logical shift left. So SHL R1, you are actually, the resultant will be what? That is 0, 0, 1, 1, 0, 0, 1, 1 and 0. And this value will be lost. Next, the CIR R1. In the CIR R1, what will be happen? Circular shift right. But whatever resultant will be come here, as in you can say that is the CIL R1 is there. Whatever result will be come here, this particular result goes here as a CIR R1, circular shift right operation. Whatever operation or the result will come, this particular as an input for the SHR R1.